Hey. Alright, what questions do you have off of this homework before we get started? I'll go ahead and tell you there will be more problems off of it tonight, and then there will be an accuracy check for it on Tuesday night's homework. So what we'll go over on Wednesday. So you need to go ahead and ask what questions you have at this point.
Shoot, I giggled.
Is this some new stuff or is this the same stuff we've been with now?
Some of it's the same. In fact, I would say that this right here is the same thing that we were working on when you left. Keep your mask up. If you don't know how I got the answers to 12 and 13, you especially need to ask questions about those.
Multiply by 3.
Oh no,
Yeah.
Right. Ain't it multiplied by 3?
But, I mean, I said R equals 3, but how did you know it was multiplying by 3?
Because 3 times 2 is 6. And
But these numbers weren't there.
okay,
You had 2
then
and you had 162.
you take 162.
Mm-hmm. 5.
2.
You making us?
No.
I feel like it's not 2. I wasn't here for
No, I got it. Hold up.
You take 162.
Is it this one where it had like
5
The
divided by
exponent.
5.
4.
Not 5, not 4.
It makes something.
What were you saying?
So
Something
isn't
it
this
called?
the one where it has to use the
Equation.
exponent and stuff?
There is a very important idea connected with exponents here. Remember, it's a geometric sequence, right?
You do it by 5.
No.
Yeah.
A geometric sequence has what type of rate of change? What is it called?
Multiplicative
It is a multiplicative rate of change, but the name is a common
ratio.
ratio. How do we calculate a common ratio?
Common ratio.
Current by previous.
What are we doing with the current and the previous?
Current over previous.
What's the mathematical word?
Current divided by previous.
There we go. So current divided by previous. Notice 162 divided by 2 is 81.
See.
But how many common ratios did I multiply by to get up to that 162?
3. 4.
4 times, right? There were 3 missing things, but it was 4 times. So, first off, what is repeated multiplication? An exponent, right? And what is the inverse of an exponent? Like what would be the inverse of a square? Square root. The inverse of a cube?
Square cube.
What?
Square cube.
No, my
Cube.
Cube root. The inverse of raising it to the 4th power would be a
4th root.
4th root, right? So that 81 is coming from multiplying repeatedly 4 times. So to undo that, I would need to do my 4th root, which is a 3. This is the idea of geometric means that we saw on 1.10 geometric meanies. I will say though that this is not necessarily my favorite way to approach it. I'll show you the way I would do it in a second. But it is good to note that it is an idea of a ratio, current divided by previous. We just have to recognize that that 81 was over 4 multiplications, so that's how we get it. Personally, and this is what we talked about before, or this is the way I recommended, is I'm starting at the number 2, bless you. Because it is geometric, I am repeatedly what?
Multiply.
And do you currently know, like we figured it out, but when you're first looking at this problem, do you know what you're multiplying by?
No.
No, so what do we use in math to represent something we don't know?
Equation.
A Y.
So x, y, those are called variables. I personally would use r because it's a common ratio, right? I would use an r there. How many times am I multiplying by r?
4.
So it would be r to the
4th.
repeated multiplication is shown through an exponent, so r to the 4th. After I started the 2 and I multiplied by r 4 times, what do I get to?
162.
And then how would I solve this?
Divide by 2.
The inverse of multiplication is division. 2 divided by 2?
1.
Okay.
We want it to be a 1. Be careful because it sometimes we create zeros, sometimes we create ones. But if I made a 0 here, What would 0 times r to the 4th be?
0.
0. I don't want 0 there. I want that r to the 4th still because I want to solve for r. That's a 1, and 1 times r to the 4th is r to the...
4.
What does r to the 4th equal?
81.
81. Notice this is showing us exactly what we did here, but to me this is a little bit more clear because what's going to be the next step to undo that 4th power?
Roots.
A 4th root.
Quad root.
Oh, that's some crazy stuff.
So r is 3. Okay? Similar thing with number 13. 1/9 times r cubed is equal to -3. Multiply by 9, because 9 divided by 9,
1, I reckon.
then a cube root. There's my common ratio. This is 100% off of 1.10 geometric meanies, and this is something you need to pay attention to. One, because the very next lesson we do, 2.4, is going to be directly built off of this idea. Two, because we struggled so much on the understanding check, I'm going to make the next understanding check actually no, not the next understanding check. For those of y'all who are just coming back, I apologize. We are having an understanding check tomorrow. But don't sweat it, don't stress it a whole lot. Don't forget, one of my philosophies is that learning never stops. So if you didn't do too hot on an understanding check, if you learn from your mistakes, and then you do better on that section on the test, I will reward that by replacing your understanding check grade with whatever you made on that section on the test. For instance, I had a student in Algebra 1B who on one understanding check had like a 70 or a 72%, and on the test, her overall grade was like 101%, and on the section that she made a 70 or 72 on, she actually made a 99. Well, I went back in and I replaced her understanding check grade with that 99 because she showed me that she learned the material to that level. Okay? So it's okay to not get it right away, but you gotta learn from your mistakes. That's why I use that rubric for grading, and I give you feedback on your assessments so that you can learn and you can grow. The point is on your growth. Not just getting a grade, not just moving through class, but to learn how things work. Yes, McKay?
Does that work for homework too?
No. Homework you gotta do. 2 out of every 3 homework grades is just, hey, did you try it? You gotta try it. And then 1 out of every 3 is for an accuracy grade. And that's always after you've done a couple for attempts. Now, I will say, just like in a college class, roughly 10% of all your homeworks, they usually drop. So if there's 10 homework grades, they'll drop 1. If there's 20 homework grades, they'll drop 2. And so I'll look to see how many homework grades we have at the end of the 9 weeks, and I'll drop 10% of them. But if you don't ever do any of the homework, can't help you too much, right? However, so if you start doing all the homework now and maybe you have less, you have more done than not done, that could bode pretty well for you.
Got you.
So we need to start doing our homework.
Starting tonight.
Heard that before, but yes, ma'am.
So you said if we were quarantined, you wouldn't put in the homework grades, or what did you say about that?
Yeah, if you're absent, then I'm not going to put in the grades.
Okay.
Yeah, you're already going to have had hard enough time by just not being here for 2 weeks. I'm not going to doubly punish you.
Okay.
Like tomorrow's understanding check will probably not be the easiest thing ever, unless you were following along with the videos I've been posting to YouTube and stuff and working through the task. But from my experience, most students aren't doing that. I would go back and watch those, especially over Thanksgiving break when you have a week off. But we do have an understanding check tomorrow, and so you'll want to learn from your mistakes and get better so that when the test comes around, you're good to go.
Okay.
We're going about PS5.
Okay. Please notice on 17 and 20, what is it just asking you to do for 17 and 20?
Solve the equation.
Really? You see solve the equation.
I mean,
Find the rate of
change.
change.
Find the rate of change.
Which rate of change?
Change in the graph.
You don't see a word right next to rate of change.
Slope.
Slope, thank you. Because if you pay attention to these things, right, we're decreasing 7, but we're adding 2, decreasing 3.5, but adding 1. No matter which way you look at it, this is a linear function because you have an additive rate of change of negative 3.5. Notice I use my slope formula of slope equals change in y divided by change in x. Change in y, remember, if you're going vertically, you would also call that your rise. The change in x was going horizontally, you would also call your run. I want you to see those connections, okay? And personally, that's what I'm always going to do. I even realized, like, so when I was doing math in high school, they always made us use the slope formula of y2 minus y1 divided by x2 minus x1. Y'all seen that before and used it, right? One day when I was teaching Algebra 1 last year, I realized all of a sudden I could keep doing that, or I could just make a quick little table out of just those 2 points and say, man, to go from 5 to 29, I'm adding 24. To go from 2 to 8, I'm adding 6. There's my rise, there's my run, my slope is 4. For me, that felt much easier than just plugging into that formula and having to memorize a formula. It's your choice, but notice if I do 29 minus 5, that's y2 minus y1, that's that 24, and then 8 minus 2, there's my 6. That just made more sense to me personally. You could also take those 2 points and graph it. Doesn't matter which way you approach it, but your slope will be 4. So hopefully we can easily do our homework tonight, especially because that means that the ready section will be taken off. You good with that, McKay?
Might get done.
Some things just never change, do they? We'll look at 2.3, we'll look at our objectives first, and then we're going to start 2.3, linear, exponential, neither. We're going to go over some of the things we talked about last week in our small groups before I just let you start working. But here's our objectives. We want to be able to identify linear and exponential functions and justify your response. Now, I want to remind and establish a couple of really important things. A linear function is just like what type of sequence? Say again? Arithmetic. Arithmetic sequences, linear functions. However, a sequence is always going to be continuous or discrete?
Discrete.
Discrete. A sequence is always going to be discrete, whereas a linear function could be discrete or continuous. It's either one. What makes an arithmetic sequence arithmetic? Because that's going to be the defining characteristic of a linear function as well. What gives a linear thing a linear shape? Yeah, not trying to trick you, it's right here. An additive rate of change. Now I'm going to go ahead and tell you, you need to learn this well because when it comes time for a test, this is no longer going to be here. It's something you got to know by the end of this unit. But an arithmetic sequence, a linear function, has an additive rate of change called a common difference, or more importantly, you usually hear it called a slope. Whereas an exponential function is just like a geometric sequence with a multiplicative rate of change and a common ratio. That needs to be a fundamental idea that you're looking at when you're trying to identify these linear and exponential functions. This number 2 is one that caused most people in here a little bit of trouble on Friday. Is that fair to say?
I conquered it.
You conquered it eventually?
We did that.
So when we look at this number 2, for those of us who are here, remind us, what type of function was this? I know.
Exponential.
This became an exponential function. What did y'all do to realize or figure out that it was exponential? You what?
I don't know. Looks like you're multiplying by 2.
Are you multiplying by 2?
No.
Yes.
You're
You're
decreasing by
dividing.
2.
No, I don't know.
Decreasing means you're subtracting. Are you subtracting by 2?
You're dividing by 2.
Okay, you could say you're dividing by 2.
Multiplying by 0.2.
Not 0.2.
0.2?
0.5.
0.2
0.5?
is 1/5. Yes. You could say you're multiplying by 0.5, which is 1/2. So 64 times 1/2. is 32. 32 times 1/2, 16. So we see, and this is an important detail to notice, because a lot of people do think division by 2. But I want you to remember and note, division by 2, notice 2 is divided by 1, that is equivalent to multiplying by the reciprocal 1/2. Because an exponential function has what type of rate of change? Multiplicative. And it's going to be cleaner to talk about it with that multiplicative rate of change. Because how do we mathematically show repeated multiplication? An exponent, right? Also, and this was something that slowed up a lot of students. First off, when we look here, we should have quickly realized it's not linear. It doesn't have an additive rate of change. But if it's exponential, it has a common ratio, which you could have done the current 32 divided by the previous 64. Hey, that's 1/2. You could have done 8 to the previous 16. Hey, that's 1/2. And notice, what are you repeatedly multiplying by? So these are things we want to keep in mind. We want to pay attention to all these different details because those could help us significantly. And so some people talked about, notice you need at least 2 reasons for your answer. Some people talked about the common ratio. Some people wrote out an equation. We're starting at 64, repeatedly multiplying by 1/2. So what do I need if I'm repeatedly multiplying? An exponent. What was my exponent in this case, though? Okay, because we did rounds, right? So f of r and r minus 1. So we needed to pay attention, though, because a lot of students wanted to just put an r up there. Isn't that what you wanted originally, McKay? Just an r for the exponent? I thought. But we had to recognize those r minus 1 because we were starting at the first round, right? Those are details we want to pay attention to. I think, if I remember correctly, some other people thought about graphing it. So rounds and players, and we went by 8 maybe? 8, 16, 24, 32, 40, 48, 56, 64. Whoops, that's not where that's supposed to be. So 1, 2, 4, and 5. So 1 round in, we had 64 people. 2 rounds in, we only had 32. 3 rounds in, we were down to 16. 4 rounds in, we were down to 8. 5, we're down into... Well, actually, when we talked about this, anyone that's ever watched any kind of sports, this should sound familiar. Because if you think about March Madness, don't you lose half the teams every round?
Yeah, it's a bracket.
Yeah, that's the same thing.
I don't know, I don't see Wisconsin.
Well, let me ask you this question. How many people are playing in every tennis match?
I don't watch tennis. One, I guess.
For real? You're going to play tennis completely on your own?
Well, okay, you're talking about the anime too, okay. 2 people.
Okay.
But then you got duos, it's 4.
Well, we're talking about singles here. So, they're playing each other, right? And one of them wins and moves on, and the other person loses.
And then
So aren't you only left with half of them?
Unless it's double elimination.
It's not in tennis. At least not in any of the majors.
How do you know
I
that?
watched my buddy play tennis once.
Huh?
How do you know that?
How do you not know that?
I did not know that.
I don't run a tennis racket.
Tennis in general, I've watched a good bit of it over time. It's single elimination at tournaments.
You should try it for
You got one
tennis.
chance. Okay.
But-
But notice, so we have these points here. Are they creating a linear shape or do they have that exponential curve to it?
It's too late.
Hey, it's got that exponential curve. That is not a linear relationship at all. And so all of these things are pointing to the fact that it's exponential. The fact that the variable is in the exponent, the fact that there's a common ratio. When we look at this graph, the fact that it has that curve instead of a straight line. Those are the kinds of things that you want to pay attention to. There needs to be at least 2 reasons for every answer that you put. Now, I do want to also point this out because I know some of us missed this detail. Right now, I have isolated points and I have not connected them. Should I leave it isolated, which is called a discrete model, or should I make it continuous, connecting those points?
Is tennis scored by 1?
Well, we're talking about human beings here,
Oh, never mind.
Discrete.
okay? We're not gonna talk about half of a round in, so we're not gonna have a point right there. You're gonna either be on the first round, or on the second round, or on the third round. So can you get stuff in between the points?
No.
No.
Mm-mm.
That's what I'm trying to explain from the context, if you're paying attention and listening, instead of just saying, I don't know. But when we look at the fact that we're talking about these rounds, you're at round 1, or you're at round 2, or you're at round 3. Another thing to think about is, if I were to make it continuous here, at some point I would have 48.5 players.
You can't
Is
have-
it possible to have half of a player?
No.
No. So we're going to model this relationship with isolated points, making it a discrete model.
True. I don't know, that's so
Okay? Another detail about that discrete, and I've said this before, pretty much anytime you're counting, which you would count human beings, it's going to be a discrete model. You measure for continuous, you count for discrete. Okay? I believe most of the groups, correct me if I'm wrong, we did number 3 already as well. Yeah? Caroline, you're just not as slick as you think you are.
I'm he doesn't understand.
So let's go and talk about 3 since most of the groups already talked about it, and then I'll let you start working from there. What type of function do you think this would be? Linear, exponential, or neither?
Actually.
You're neither?
Linear.
You're linear?
I don't know. I just,
So we all in agreement it's not exponential then?
okay, sure, yeah.
Why is it not exponential?
Because,
Because what?
it's a great question.
It's not an exponent.
There's not an exponent there, so that might make sense that it's not exponential, right? Something I want you to remember is a lot of students like to just look at it and know things. You gotta quit doing that. Take some time to think about things. What type of mathematical representation is this? It's got variables and numbers.
Linear.
It's,
Real.
What type of mathematical representation? What are the mathematical representations? Verbal,
table, graph.
tabular, graphical,
Pictorial.
pictorial,
What else did you say?
algebraic. This is literally called algebraic connections. Trying to see the connections between the algebraic and other representations here. This is algebraic right here. Could you make another representation to make sense out of it?
Mm-hmm.
What about a table?
Yeah.
Sure. What's 4 times negative 2? 4 times negative 1.
-4.
4 times 0.
0.
4 times 1.
4.
4 times
Sir,
2.
Alan.
Does anyone see a pattern in that table that might be helpful?
Adding by
4.
If we're repeatedly adding by 4,
That's why it's shown in that multiplication right there.
it's going to be linear. And say that again, McKay?
That's why it's shown in the multiplication.
Yeah, isn't multiplication simply repeated
Addition.
addition? Those are connections we want to see.
That's what I have wrote down.
Good. And then if you wanted to, you could even make a graph out of something like this. So -2, -8, -1, -4, 0, 0, 1, 4, 2, 8. Does that look pretty linear to you?
It looks pretty straight, so yeah.
Yeah. Right? There are multiple ways to do this, but this is what I need you to understand is stop sitting around and be like, I don't know the answer. Cool, make another representation. Make a table, make a graph, make something to make sense out of the problem. We want to sit around and be given answers instead of taking the time to say, okay, so what can I do? And that's an important lesson for life after high school too. I've seen a lot of adults who have struggled in jobs or lost jobs because they want to sit around and they want to wait on someone to tell them exactly what to do. That's not what employers want. They want someone who can take the information that they have and figure out what to do from there. This is an important skill. So let's go ahead and get working. Make sure you're talking with your partner to see if you have any questions or how you would approach these kind of things. And I'll be coming around and seeing how you're making sense out of it.
You know,